Good afternoon. My name is Heinrich Lenz. I was born on February 12, 1804 in Tartu, Estonia. I studied physics and chemistry at the University of Dorpat, and still very young I took part as a geophysicist in an expedition around the world, during which I made measurements on the level of salt, temperature and pressure of seas and oceans. Later I settled in St. Petersburg, and I was a teacher at the University and the Academy of Sciences of this city, of which I will become dean and rector. Lenz's name, or at least my first initial, was attached to still one more area of physics, nomenclature. The symbol L was chosen to represent inductance in honor of my pioneering work in electromagnetism. I showed a great interest in the area of electromagnetics, which let me discover the laws of Ohm and Ampere. I insisted on verifying the principles that these authors managed to establish, and I succeeded in 1832. I carried out different experiments that allowed me to determine the quantitative laws of induction. With the results I obtained, I was able to create a ballistic galvanometer. By 1833, I presented to the scientific community a series of findings that I had achieved in the field of electromagnetics. I explained the fundamental law of electrodynamics, which is known as Lenz's law. The direction of the induced current will be such that its flow opposes to the cause that produces it. This law states that any electromagnetic phenomenon has to do with mechanical energy that is wasted. The conclusion that electromagnetic phenomena have to do with wasted mechanical energy was born from observing that external force causes a magnet to move near a closed conductor. The mechanical energy is then converted into electromagnetic energy from the induction current. According to my law, the force was applied to block the movement by which it's originally caused. That means if you are in the presence of a magnet and it's necessary to make a greater expenditure of energy than when the magnet was absent. My law was based on proposals from Michael Faraday, and it completed the studies that had been conducted. This law is sometimes referred to as Faraday-Lenz law. Let me try to explain you the principle of the Lenz law. The experiment consists of observing the change of direction of the magnetic flux. For this, we need copper coils, a magnet, and a multimeter that will help us to visualize the change of sign in the voltage. This means that there will be a change in the direction of the magnetic flux. The voltmeter is on the 200 millivolt scale at the direct current. As you can see, if I leave the magnet into the coil, there is no current flowing, the voltmeter shows practically zero. But if I move toward the magnet, towards and backwards, the copper coil, we can see how the voltage oscillates between -11 and +11 millivolts. That there is a current flowing through the coil and it changed direction. This was my contribution to Faraday's law to determine the direction of inductance current. Also, I analyzed the amount of heat released by currents in the conductor. The findings derived from these studies were of great importance to science. It was in 1833 that I discovered that there was a connection between the electrical conductivity of metals and the degree of heating. That is why I designed an instrument that made it possible to define the amount of heat that was released. As a result, the Joule-Lenz law was born. The double name is due to the fact that the English scientist James Joule presented his version of the law almost at the same time as mine, although we never worked as a team. I died suddenly on January 10 of 1865 when I was in Rome, Italy. I went to that country to receive a night treatment, but after suffering a stroke, I was buried in Rome.